By 2050, new technologies will have completely reshaped our planet and how we live on it. Today, I'm diving into 5 futuristic technologies that will change life itself. Let's get into it. Nanobots are microscopic robots, often as small as cells, capable of doing tasks at the atomic level. What makes them even more powerful is their potential for self-replication. This means they could multiply, carrying out massive tasks way beyond their initial numbers. This technology would allow us to repair, build, and transform things on a scale that is almost unimaginable today. Picture this: a swarm of nanobots roaming your body, monitoring your health, repairing tissue, and preventing disease before symptoms even appear. Nanobots could deliver drugs directly to infected or damaged cells, avoiding side effects and increasing the effectiveness of treatments. Chemotherapy, for example, could be replaced by nanobots that directly target cancer cells, leaving healthy ones unharmed. Or imagine entire cities being built by nanobots, molecular layer by layer, with almost no human labour involved. Imagine buildings and infrastructure that never break down. Nanobots embedded in concrete or steel could automatically detect structural weaknesses or damage without the need for humans, making the lifespan of bridges, roads, and buildings so much longer. One of the most exciting possibilities for nanobots is their ability to break down pollutants. Fleets of nanobots could be released into the ocean and could target oil spills, heavy metals, or microplastics, removing them at a molecular level. This would restore ecosystems without the need for human intervention. Currently, nanotechnology is being used in limited ways, such as drug delivery systems. However, self-replicating nanobots are still at the theoretical stage. Scientists are currently working on developing smaller, smarter, and more autonomous nanobots, and by 2050, they could be the most revolutionary technology that we've ever created. The hyperloop is a next-generation transport system that aims to move passenger pods through low-pressure tubes at up to 760 miles an hour, close to the speed of sound. By using magnetic levitation in near-vacuum conditions, the hyperloop allows for incredibly fast and energy-efficient travel. Think bullet train, but no tracks for added friction and barely any air resistance, so they move so fast. The hyperloop could decentralize cities and redefine where people live. Today, people tend to live near to where they work, resulting in overcrowded, expensive urban areas. Imagine someone living in Nevada, surrounded by nature, but working in downtown Los Angeles. This commute would usually take hours by plane, but it could just take a single hour with a hyperloop. This would reduce the pressure on urban housing markets and improve the quality of life for millions. The hyperloop could also significantly cut down on short-haul flights, which are a massive contributor to CO2 emissions. Domestic flights, especially those under 500 miles, would become obsolete as the hyperloop would offer a faster, more affordable, and greener solution. Companies like Virgin Hyperloop have already completed successful trials with passenger pods, but scaling the infrastructure is the current problem. This requires building extensive tube networks and getting government and regulatory support. However, several countries, including the US, Saudi Arabia, and India, are exploring the early adoption of hyperloop systems. By 2040, we could see commercial hyperloops in action, and we could see widespread use by 2050. Fusion power might be the closest thing we get to a limitless energy source. It's based on the same process that powers the sun, smashing hydrogen atoms together to create energy. Unlike fossil fuels, fusion power creates no greenhouse gases, no long-term radioactive effects, and the fuel, hydrogen, is practically limitless. By 2050, fusion could power the world's cities without ever running out. Imagine New York, London, Tokyo running on clean energy, no CO2 being thrown into the atmosphere. Fusion energy could also make electricity dirt cheap. Think about your monthly energy bill. That number could go almost to zero. On a larger scale, this could end energy poverty. Fusion could bring affordable power to the most remote regions of Earth, transforming lives and boosting economies. Factories would run non-stop on clean power, and electric vehicles would be so cheap to run. Even your own home could be powered by a mini fusion reactor. Energy from fusion could improve desalination technologies, turning deserts into farmland and helping the 55 million people severely impacted by droughts every year. Imagine places like the Sahara Desert or Australia's outback becoming fertile farmlands because fusion-powered plants can make seawater drinkable and irrigation cheap. Fusion could even make deep space travel feasible. That's right, currently spaceships are limited by fuel, but with fusion, we could make spaceships with near unlimited fuel, allowing humans to colonize Mars or even go deeper into space. Fusion seems like a no-brainer, right? So why isn't it powering our world yet? The short answer is that fusion is incredibly difficult to achieve here on Earth. To fuse hydrogen atoms, you need to achieve conditions similar to those of the sun's core, temperatures of over 100 million degrees Celsius. That's nearly 10 times hotter than the sun's surface. The problem is maintaining those extreme conditions long enough to get out more energy than you put in. Current experiments can achieve fusion, but we still use more energy in the process than the energy that we get out. Right now, the ITER reactor in France is one of the leading projects working to make fusion a reality. They're aiming for their first fusion reaction by 2025, with their first commercial reactors potentially online by 2040. So while fusion isn't powering our homes yet, it's no longer a pipe dream. By 2050, fusion power plants could be the global standard for energy. Digital immortality refers to the concept of uploading human consciousness onto a digital platform, allowing humans to live on in a digital form after their biological bodies die. This would involve mapping the brain in such detail that every personality trait, memory or thought can be uploaded into a virtual world. In essence, it would mean living forever, but not in the way that we traditionally think about it. In a world with digital immortality, death would no longer be the end, but more of a transition. Instead of traditional funerals, we might hold uploading ceremonies where families would gather to see someone's consciousness uploaded into the virtual realm. The line between life and death would blur, and people would live on as digital entities capable of interacting with the physical world via avatars. Religious and cultural concepts of the afterlife would be challenged. Would digital immortality be considered a new form of existence? Some might see it as a way of avoiding death altogether, while others will grapple with the idea that a digital version of a person is truly them. With digital immortality, experts and thought leaders from all different fields, science, politics, arts, could be preserved and accessed indefinitely. Imagine a world where Einstein, Steve Jobs, or even Queen Elizabeth II could live on and continue to share their knowledge with future generations. One of the biggest ethical questions is, who owns your digital self? Is it you, your family, or the company that hosts your digital consciousness? What happens if a corporation decides to manipulate or even shut down your digital self? Would you have digital rights, or could you be edited, copied, or erased by others? Companies like Neuralink are already trying to create brain-computer interfaces to link the human brain to the digital world. While they're still in their early stages, memory uploading experiments in mice have already been completed, and scientists have successfully moved a memory from one mouse to another. By 2050, the first forms of digital immortality could be available, especially to those that can afford it. This one is such a complex topic, and I could be here for days talking about it, so stay tuned for a video I'll create on it in the future. Artificial General Intelligence, or AGI for short, refers to a form of AI that can understand and perform any intellectual task that a human can. Unlike the AI that we have today, like voice assistants or self-driving cars, AGI would be capable of independent thought, learning from experience, and applying intelligence across a range of different fields. Whether it's designing a new product, identifying a medical condition, or even understanding human emotions, AGI could do it all. AGI could transform healthcare and become the ultimate doctor. It could instantly analyze vast datasets such as patient history, genetics, environmental conditions, and even cutting-edge research to instantly diagnose illnesses with extreme precision. AGI could operate at the helm of businesses, making data-driven decisions faster and more accurately than any human executive. With AGI capable of handling virtually any intellectual task, millions of jobs will likely be automated. As AGI takes over more roles, humans might even have to rethink their role in society. Society may have to restructure around leisure, with more people exploring art, personal relationships, and emotions rather than work. This could also lead to existential questions about what gives life meaning if there's no longer traditional work to do though. AGI could design and build new technologies far beyond what human engineers could create. AGI could even improve itself, leading to rapid cycles of innovation. As AGI becomes more advanced, the biggest question will be who controls it. Should governments, corporations, or international bodies regulate AGI development? And if AGI becomes self-improving and independent, could it escape human control? If it is capable of independent thought, should it even have rights? Current AI systems like ChatGPT-4 are impressive, but still limited to specific tasks. AGI is the holy grail of AI research, and AI experts predict that we could see rudimentary versions of it by 2045. By 2050, AGI might be fully operational, working alongside or even above humans in various fields. These technologies are right around the corner, and by 2050, they might be shaping the very fabric of our society. Which one are you most excited or worried about? Drop a comment below and let me know your thoughts.